Welcome to the tutorial on advanced LaTeX packages and graphics integration. I am Kishore Datta from Henry Girls College, Guwahati. In this session, we will explore some advanced LaTeX packages that facilitate algorithms, graphics, and code formatting. Whether you are a beginner or seeking to expand your knowledge, this tutorial offers step-by-step guidance with practical examples to help you master these packages. After going through this tutorial, you will be able to apply the algorithm and algorithmic packages to format and present algorithms effectively. Write and format pseudocode using LaTeX for clear and professional presentation of algorithms. You will be able to integrate external graphics into LaTeX documents using the graphics package. You can create custom diagrams, illustrations, and figures using the TXZ package. You will be able to format source code listing within LaTeX documents using the listing package. And finally, you will be able to customize and enhance the appearance of source code with syntax highlighting, line numbers, and other formatting options. So let's begin with the algorithm and algorithmic packages. These packages make it easy to format algorithms in a clear and organized way. The algorithm package helps by adding features like automatic numbering, titles, and references for algorithms in the text. The algorithmic package focuses on defining the steps in an algorithm. It includes ready-made commands for common programming structures, making algorithms easy to follow. These structures include for that creates a loop to repeat actions over a range of or list of values, while that runs a loop continuously as long as a given conditions remain true. If that defines condition that determines whether a specific blocks of code is executed. Else, if, and if. This completes the conditional statements by specifying alternate actions or marking the end of condition. Let me open the text up and write the basic structure of an algorithm within algorithm environment. So I am writing begin algorithm and then an algorithm. Now I am giving the commands. First, let's say the caption. I am writing the caption of this algorithm as algorithm title. Then I can include algorithmic environment, begin algorithmic, and algorithmic. Then, as I stated earlier, there are commands state, all are capital letters, text BF, input, colon, description of inputs, again state, text BF, output, description of outputs, again slash stat, initialize variables or set initial conditions. Then for statement. Within for I am writing each item in the dataset. Again I can write if condition. Within if I am writing condition is met. Again state, execute specific action. then and if, all are capitalized, then N4, then again state, finalize, and return the result. So as we see here, the algorithm environment begins with a title for the algorithm set using the caption command. Inside the algorithmic environment, each line of the algorithm uses commands like state to specify individual steps, for to start a loop, and if for conditional statements. Commands such as N4 and if indicate the end of loops and conditionals. So here is the output, which shows a highly structured, clear format for documenting algorithms. Let's take an example, finding maximum element in an array, and let's write the algorithm. So I am writing begin algorithm, an algorithm, and then caption, find maximum element, then begin algorithmic, an algorithmic. Within begin algorithmic and algorithmic, there are states. So first state is input, and then I am writing array, capital A, of n elements. Then again state, output, all are bold-faced, maximum element in A, then again state, initialize, max, then within dollar gets A1, gets is a command here, then for loop, within for I am writing each element x in A, if x greater than max, so max I am writing within text, then again state, max gets x, then end if command, N4 command, then final statement, return max. So this is displayed as I am showing here as a structured algorithm for finding maximum element in an array. Let's proceed and look at the graphics package. I am centering the figure, so I have to use centering command, /centering. Then the main command include graphics, width equal to, let's say, 0.5 text width, and then the image file name example.jpg. I can give a caption here. I am writing an example image, then I can label it, let's say figure example. So this will show the image at the center position of the page. Let's look at the TXZ package. The TXZ package is particularly beneficial for designing diagrams, flowcharts, and other intricate illustrations directly in the document. So it can be used by adding in the preamble use package TIGZ. So here is an example. I am writing begin TIGZ picture and TIGZ picture, and within this environment I can choose use TIGZ library. There are many libraries. I am choosing shapes and snacks. Now the commands are /draw, tick from 0 0, and the shape is rectangle, and it goes to 2 1. These are the coordinates. Then I can draw three zero double hyphen 40 double hyphen 3.52, and then again double hyphen cycle. This will create a triangle. Then I can write /draw. I can fill the diagram, so I can use fill equal to blue, let's say 20%. So the coordinate is 5.5, and the shape is circle. If it is circle, then I have to declare the radius, let's say it is 0.5. Then I can use another command for ellipse, /draw. Let's say the color is red and the line is thick. And the XY coordinate is 0.5. Shape is ellipse. Semi-major and semi-minor axes are 0.8 and 0.4. 7. And I can draw a line using draw, then hyphen and arrow, tick from 0.5 to 8.5. So all these commands in TIGZ picture creates all these figures. You will see here a rectangle, a triangle, a circle, an ellipse, and a line. So coordinates, you can change the coordinates and you can display them at different locations of your A4 size paper. Now let's look at how to create a flowchart with TIGZ. So again I can use begin TIGZ picture and TIGZ picture. Within this environment I am again using use TIGZ library, shapes and snacks. Now in order to draw the flowchart I have to use the command node /node draw rectangle, then start at coordinates 0 0, and the text will be start. Again I can repeat node draw rectangle, and it will be decision at coordinate 0, -2. Text will be decision, and similarly node, draw rectangle, yes, -2, -4. Node, draw rectangle, no at 2, -4. Then draw arrow, start to decision, draw arrow, decision to yes, draw decision to no, and then end picture. Now, as shown in the output, the diagram consists of 4 rectangular nodes representing different stages of a process. The first node, labeled start, is positioned at coordinates 0, 0. The second node, decision, is placed below it at 0, -2, followed by the yes and no nodes, which are placed to the left and right of the decision. The nodes are defined with the draw options to outline the rectangles. The arrows connecting the nodes are drawn using the arrow notation, indicating the direction of the flow from one step to the next. Let's look at creating the flowchart with TickJet picture. As we have shown earlier, the simple TickJet picture command creates a flowchart as shown here. Now let me modify this one and make it an advanced flowchart with TickJet. For this I have to use some other syntax. Let me copy this one and paste here. The same code I am pasting here, and now I am modifying node draw and then fill equal to blue 20%, and then the shape is rounded corners, and font is, let's say, BF series, text centered, and then inner shape equal to 10 points. So this is the first node. I have used some simple syntax, so it looks like this one, start. Let's modify the second node. I'm copying the same thing and replacing here. Now I can change the color. So everywhere I'm replacing the same thing, and now I'm replacing the color, let's say yellow, green, and red. All are 20%. So now as you see here, it looks far more attractive than the previous one. So I can change the color, let's say full red, then it appears full red. So this way you can create a more advanced flowchart with TickJet. And the arrows, I can change the style of arrows. So I am adding thick blue, and I am adding everywhere. So all the 3 thick lines appear blue. Now let me show you how to create flowchart with different node shapes. So node shapes, instead of rectangle we can use ellipse, circle, etc. So let me show here. Instead of rounded corners I can write ellipse. Then I have to define the coordinates properly. Let me keep them fixed as the previous one. I am just changing the rounded corners to ellipse. Let me add one more node here and change the decision to process. Because I want to add one more node here in between. I am changing now. I am writing it as decision. The node name is decision and coordinates are also different, and it will type decision within the node. So the final node will display stop and its location is, let's say, 3 and -6. Now so I am adding one more node and the label is, let's say, end, and the node will type end and its location is 0 to -8. Now let's look at the arrows. So I have to declare 5 or 6 arrows to connect all the nodes. First one is from start to process. Second one is from process to decision. Third one is from decision to yes, then decision to no, and then I need two more. One is from yes to end, and the other one is from no to end. So no to end I have to connect now. So here is the no and then to end. So this way you can create a visually attractive flowchart with different shapes of nodes. I am using here ellipse and rounded corners. Now let's look at how to create or adjust layers and transparency using TXZ. So let me write the command here. Begin center and end center. I have to declare begin TXZ picture. And TXZ picture, and then I want to draw a semi-transparent red circle. So my command is fill and then the color is red. Opacity is, let's say, 0.5 and the location is at 0, 0 and the shape is circle with radius, let's say, 1 centimeter. Every such command line should be closed by semicolon. Then I want to draw a semi-transparent blue circle overlapping the red circle. Opacity I am keeping the same, 0.5, and then the location of the side of this circle, blue circle, is, let's say, 1 and 0 with the same radius, 1 centimeter. Now I can run this program. As you see here, there is a overlapping circle of two different color. I can increase the radii of these two circles. So it looks like this. Next, we can see we can use the same method for different shapes. For example, I can define a rectangle from -2, -1 to 2 1, let's say 2 1, and then I can define a transparent yellow ellipse, yellow, opacity is let's say 0.6 or 0.5, 0.6. Then the ellipse, center of the ellipse is 0 0, with semi-major and semi-minor axes are 1.5 centimeter and 0.5 centimeter. So this command will draw a transparent green rectangle and a transparent yellow ellipse as shown here. So transparency can also be combined with patterns for unique effects. For example, let me show here. So I am copying the same code here for transparency or for transparent patterns. So I am to draw two different patterns. Let me show you here how to create two different patterns, overlapping patterns. So in order to do this, I have to use TXZ library patterns. This is important, patterns. Then within begin TXZ picture and TXZ picture, I can describe a transparent striped pattern. So my command will be fill patterns, let's say northeast lines. So lines are inclined lines. Then pattern color equal to red, opacity equal to let's say 0.5, and the coordinates are 0 0. It starts from 0 0 and ends at let's say 4 and 3. Again I want to draw a transparent grid pattern. So the command will remain same, only options are different. So grid pattern, so I have to replace northeast lines by grid. Pattern color is let's say blue, opacity is let's say 0.3, and the rectangle starts from -2, -1, 3, 2. Let's see how it works. So it will create two rectangular patterns as shown here with different colors and different inclinations. One is grid pattern, another is northeast lines. So this way we can create patterns of different shapes, different colors, etc. Now let's see how we can highlight specific overlaps using TXZ picture. To highlight specific overlaps, I am using red color. I want to draw a red circle with opacity 0.5, and the coordinate is, the origin is at 0 0, and radius is 2 centimeter, let's say. And then again a blue circle, so the color will be blue, opacity is the same 0.5, and the origin of the circle is at 2 0, and radius is the same 2 centimeter. Then to highlight specific overlaps, we have to use the begin scope and scope environment. Within begin scope and scope, we have to define clip 0 0, circle 2 centimeter, and then we can define the other features using fill. Then what is the color of the overlapping region? Let's say green. Fill green, opacity let's say 0.7, and then the origin of the circle is 2 0, circle 2 centimeter. So this will display two overlapping circles and it highlights the specific overlaps as shown here with green color. Next, let's look at how to draw graphs and trees using TXT library. The simplest form of a tree can be drawn with parent and child nodes using the child keyword. I will show you here in this simple code. I am writing here begin center and center, begin TXT picture, and then end TXT picture. Then I have to define a node, and node name is root, and then within root I have two child, C small, the node name is left, let's say, again another child, and node name is right. One is left, another is right. So this will display a simple graph with two child as shown here, root, left, right. The next, we can design this graph. You can style the node to enhance the appearance of the tree by adding shapes, colors and formatting options. Let me show here. So we can use the same code, only we have to modify it slightly. So after describing the TXT picture environment, we have to design two styles. One is level 1, let's say label name is level 1 slash dot style equal to sibling distance. Sibling distance is the horizontal distance between two nodes. Let's say it is 4 centimeter. Then level 2, one is level 1, another is level 2, and sibling distance is, let's say, 2 centimeter. And within third bracket I have defined these levels, and then we can now describe the nodes. The root node, we can design it. So all the options we can write here: draw, circle, and the color fill equal to blue 20%. Similarly, the child node, we can use draw, circle, fill, red. So I am changing the color here. So this is red, let's say. And similarly for the second child, I can use the color green or yellow. Let's say green. Now you will see here. So the previous graph becomes this one with all color nodes and shapes are circles. So to create more labels by nesting the child commands. Let me show you an example how to create more labels using child command, nested child command. So I am copying the same previous code and I will modify here. So sibling distance I am changing it to 6 centimeter and 3 centimeter. Now the root node remains the same, but after root node there is a left child node, and within this child node I am creating another child by using nested child command. So child, my new child will be child node draw circle fill yellow, and this child name is left. I need another child with name left right, so I'm doing here, and color is, let's say, again yellow. So the same line I can copy, and then I can change the name of the child node to left right. So this way this produce left and left right, two different nodes, child nodes. And similarly the right node, right child node, in the right child node we can nest another two child node with named as right left and right right. Right right. So this completes the whole code, and this will display the graph. From root there are two nodes left and right, and from this left and right there are two child. It's one is left right, another is right right as shown here. So this way you can modify the nodes, their shapes and colors, and you can create visually attractive graphs and trees. To create edge connected nodes within the centering environment, I am showing a simple example here. So how to create edge connected nodes using TickJet picture. So the first command is to define nodes. Let's say node, I want to draw a circle, so draw circle, and it is labeled as A at which coordinate 0 0, and then within curly bracket A. Then I want another circle labeled as B at 2 2, and named it as B. Another circle labeled as C at 4 0, and named it as C. And the last circle labeled it as D at 2 -2, and named it as D. So this will create 4 nodes A, B, C and D at 4 different locations. Now I want to connect these nodes with edges, so I have to draw dotted line A to B, then again a line from B to C, then C to D, D to A, and let's say A to C. Let's see how it works. There is an error, it shows something is wrong here. So can you identify where is the wrong mistake? The labels A, B, C, D should be same everywhere. So superscript and subscripts, or capital letters and small letters, are identified differently. So as we see in the second line, draw B to C. C is small here, So that is the error in the error message. So you have to correct it, because we have labeled the nodes as capital A, B, C and D. While drawing circles using note command, we have used capital A, B, C and D, and while drawing the lines, we have to use the same labels, not small letters. So as you see in the second line, if I replace small c by capital C, then everything will be fine, and you will see the graphs with edges as shown here. So the directed edges can be drawn with arrow. So just in the draw command, we can use arrow lines with directed edges. To create edge connected nodes with directed edges, you just add arrows after draw command. So this will work. As you see here, all R becomes arrow. Now let's look at the listings package. The listings package is widely used to display source code in LaTeX documents. It provides a variety of options for customizing the appearance of code, such as syntax highlighting, line numbering, and background colors. To use the listings package, the command use package listings should be included in the preamble. This will allow you to use the listings environment to include code snippets directly in your document. The simplest way of writing a basic Python code using LST listing environment is shown below. So I am using LST listing environment. So I am writing begin LST listing and LST listing. Within this LST listing environment, let's write numbers equal to 1, 2, 3, 4, and then squared. I am defining as x squared for x in numbers. Then I can use print squared. So this snippet is shown here. The code is displayed in a monospaced font with proper indentation, making it easy to read and distinguish from regular text. The LST listing environment automatically handles special characters and ensures that the code is displayed exactly as written. The listing package allows customization of code appearance, including language, background color, etc. I am writing an example. So the command is lstset, then within second bracket, language equal to, let's say, Python. Then background color, I am choosing light gray, so /color light gray. Then basic style, TT family. Keyword style, so color blue. Comment style /color gray. String style /color red. Numbers left. number style, tiny, color gray, then frame equal to single, break lines equal to true. Then I can write again the same code, begin LST listing, numbers equal to 1, 2, 3, 4, squared equal to x square for x in numbers, and then print squared. So as you see here, there are different colors for comments, keywords, and numbers. Now that we have covered the key concept in this part of the tutorial, let us take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. Take a moment to think about your answer. What command is used to specify the title of an algorithm? The options are state, caption, begin, and end. So as we have discussed already, the correct option will be B, the caption. Caption command is used to specify the title of an algorithm. The second question is, in the provided example, what is the purpose of the N4 command? The options are to start a loop, to initialize a variable, to end a loop, and to display the output. So the correct answer is to end a loop, because it is N4 command. N4 command, as we have discussed already, it is used to end a loop. Question number 3. Which package is used in LaTeX to include and manage images? Options are TXZ, graphics, geometry, MS Math. Obviously the correct answer is graphics. Graphics is a package which is used in LaTeX to include and manage images. Let's see the next question. Which package is used in LaTeX to create vector-based diagrams and figures? Options are graphics, TXZ, MS Math, float. The correct answer is TXZ. Let's look at the next question. The listings package is primarily used to, options are insert images, create tables, format code listings, and display equations. So the correct answer is format code listings. Let's look at the last question. Which option is in LST set changes the color of comments in code listing? Options are background color, keyword style, string style, and comment style. So the correct answer is comment style, that changes the color of comments in code listings. So to summarize, in this tutorial we have mastered advanced LaTeX packages for algorithmic typesetting and pseudocode formatting. We have integrated external graphics and created custom diagram using graphics and TXZ packages. We have formatted source code listings and customized their appearance with the listing package. Thank you.